in this problem, we have to approximate the gravitational force exerted on the moon by Earth and the sun during the solar eclipse and the lunar eclipse. And here it is given the mass of the earth, mass of the sun, mass of the earth, mass of the moon, the radius of the earth's orbit around the sun, the radius of moon's orbit around the earth, and the value of gravitational constant. And here we have to find whether the force on the moon during the solar eclipse is greater or less than or equal to the force on the moon during the lunar eclipse. So let's do this question. So in this question, all these things are given: the g, mass of the earth, mass of the moon, mass of the sun, the radius of the earth's orbit around the sun, and the radius of the moon's orbit around the earth. First, let's find the force exerted by the earth on the moon, which is equal to FEM is equal to g, the mass of the earth, mass of the moon, divided by REM square. So here we'll put all the values. G is equal to 6.6 into 10 raised to power minus 11. Mass of the earth is equal to 6 into 10 raised to power 24. The mass of the moon is equal to 7.4 into 10 raised to power 22 divided by REM, which is equal to 3.8 into 10 raised to power 8 whole square. If we solve all this, we'll get FEM is equal to 2.05 into 10 raised to power 20 Newton. So let me mark this as my equation number 1. If we see this picture, then we can see that during the solar eclipse, the moon will come in between the sun and the earth. The force exerted by sun on the moon is equal to g, the mass of the sun, the mass of the moon, divided by the distance between this sun and the moon, which I am representing with SM whole square. I have to find the value of RSM. So if we see this picture, the distance between the sun and earth, ES, is equal to this distance plus from here to here distance, so which is equal to RSM plus REM. So from here we'll find this RSM, which is equal to RES minus REM. RES is equal to 1.5 into 10 raised to power 11 meter minus REM, which is equal to 3.8 into 10 raised to power 8 meter. So here we'll solve this and we'll get, okay, to solve this I am taking 10 raised to power 11 out. So inside we will be left with 1.5 minus 0.038. Now we'll subtract them, will get equal to 1.462 into 10 raised to power 11 meter. Approximately we can write this as 1.5 into 10 raised to power 11 meter, which is equal to the radius of the earth's orbit around the sun. The force between the sun and the moon is equal to 6.6 into 10 raised to power minus 11 into the mass of the sun, 2 into 10 raised to power 30, the mass of the moon 7.4 into 10 raised to power 22 divided by this 1.5 into 10 raised to power 11 whole square. If we solve all this, we'll get 4.39 into 10 raised to power 20 Newton. So if we see this picture, we'll find the gravitational force exerted by the sun on the moon will be in this direction, and the gravitational force exerted on the moon by the earth will be in this direction. So during the solar eclipse, earth and sun, they will apply the gravitational forces on the moon in opposite directions. So net force during the solar eclipse on the moon, we can write here as F solar is equal to F FSM minus FEM. So this FSM, we have this value 4.39 into 10 raised to power 22 minus FEM. We have got this in equation 1, which is equal to 2.05 into 10 raised to power 20. So this is Newton, which is equal, if we solve this, we'll get 2.34 into 10 raised to power 20 Newton, and this force will be towards sun, as this the force on the moon due to sun is greater than the force on the moon due to earth. So net force will be towards sun. And during the lunar eclipse, earth comes between sun and the earth, and the total distance between the moon and the sun, which is equal to SM, in this case will be equal to RES, this distance plus REM. So in this, here we'll find RSM first, which is equal to RES, which is equal to 1.5 into 10 raised to power 11 plus 3.8 into 10 raised to power 8 meter. So here we'll get 1.5 into 10 raised to power 11 plus 0.038 into 10 raised to power 11, which is equal to, now I'll take this out, 1.5 plus 0.038 is to power 10 raised to power 11, which is equal to 1.538 into 10 raised to power 11, which is equal, approximate value I'm going to take here, 1.5 into 10 raised to power 11, which is equal to RES. So now the gravitational force exerted on the moon due to sun is equal to G, mass of the sun, mass of the moon, divided by RSM square. So if we put all these values, we'll get same value, 4.39 into 10 raised to power 20 Newton. The gravitational force exerted on the moon due to sun will be in this direction, and also the gravitational force exerted on the moon due to earth will also be in the same direction. So earth and sun will apply the gravitational force on the moon in the same direction during the lunar eclipse. So here the net force on the moon during the lunar eclipse will be equal to FSM plus FEM. So this is equal to 4.39 into 10 raised to power 20 plus the force exerted on the moon due to earth, which is equal to 0.5 into 10 raised to power 20 Newton, which we have taken from the equation number 1. So if we add these two, we'll get 6.44 into 10 raised to power 20 Newton. So the force during the lunar eclipse on the moon is equal to 6.44 into 10 raised to power 20 Newton, and it will also be towards sun. So if we compare these two forces, means the force on the moon during the solar eclipse, which we have got 2.34 into 10 raised to power 20 Newton, and lunar eclipse is equal to 6.44 into 10 raised to power 20. So from these two relation, it is clear the net force on the moon during the solar eclipse is less than the net force on the moon during the lunar eclipse.